SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Good afternoon. As a part of BISEC Mathematics Lecture Series, today I am Jagrut Tripathi coming from Christ College, Rajkot, going to deliver a lecture in the topic of polar coordinates. Polar coordinates, as we all know, we are having the presentation system of coordinates in Cartesian form since our school levels. But now we are going to discuss the concept of polar coordinates. Polar coordinates is nothing but the another way of representation the points or equations in 2 or 3 dimensional planes. As a part of polar coordinates, we have various applications in the mathematics like representation of the polar coordinates and equations in polar form, representation of straight line or a circle in a polar form, the distance between 2 points in polar form, and the relationship of Cartesian coordinates with the 3-dimensional spherical and cylindrical point. So, as a part of applications, we begin our lecture with the relationship between Cartesian and polar coordinates. For that, as a part, you consider a triangle, say right angle triangle ABC, in which angle B is considered to be a right angle. Let us consider this angle ACB as theta. Also, let us note the sides AB as Y, BC as X, and AC as R. So, according to the Pythagoras and trigonometry, let us define cosine theta first. Cosine theta is equals to, according to the trigonometry, x upon r. Sine theta is equals to y upon r. So the basic relationship we can settle down as x is equals to r cos theta, y is equals to r sine theta. So this is what the basic relationship between the Cartesian and the polar coordinates. Now, if we have the values of x and y, we can find out the values of r and theta accordingly, like r can be found as under root of x square plus y square, and this theta can be found as the very basic relation y upon x, that is tan inverse of y upon x. For more details, let us try to consider some examples related to that. So we begin with the conversion of Cartesian coordinates into polar form. Let us take an example, say -1 is to be converted in terms of polar form. So we have x is equals to -1 as the x coordinate, y is equals to -1 is equal that is y coordinate. So now we can compare with the polar form, that is r cos theta is given to us -1, r sin theta is also -1. And now, as the formula we derived earlier, r is nothing but under root -1 square plus -1 square, that is root 2. And so that we have cosine theta is equals to 1 upon root 2, sine theta is equals to again -1 upon root 2. As we have both the values in negative form, the value will definitely lie in the third quadrant, in which the value of theta is pi plus pi by 4. The answer will be nothing but 5 pi by 4. In short, the polar coordinates for the same is converted in terms of r theta is equals to root 2 5 pi by 4. For more understanding, let us take one more example for the same. Now, second question, that is convert -1 and root 3 into polar form. For the same sake, we'll take x is equals to -1, y is equals to root of 3. Now, as per the polar coordinates form, r will be found as x square plus y square. So usually it is nothing but under root of 1 plus 3. Answer will be 2. After finding out r, we can definitely obtain sin theta and cos theta accordingly. That is y upon r, that is root 3 upon 2, and cosine theta is x upon r, that is minus 1 upon 2. As x is minus, y is plus, the value will be lying in the second quadrant, and second quadrant the answer will be pi minus pi by 3. The answer is 2 pi by 3. So these coordinates are now r theta equals to 2 pi by 3. So likewise you can settle down as many equations, as many coordinates for the Cartesian to polar to be solved. Now let us take few examples from polar coordinates to Cartesian coordinates. In this kind, you will be given the polar coordinates and now you are supposed to convert it in terms of Cartesian form. Say for example, we are taking one polar coordinate as r theta equals to 1 pi by 2. So 1 pi by 2, r is 1, theta is pi by 2, and we have the very straightforward relation x is equals to r cosine theta, y is equals to r sine theta. So we have 1 into cosine pi by 2, y equals to 1 into sine pi by 2. And with the very basic trigonometry idea, cosine pi by 2 is 0, x is equals to 0, and sine pi by 2 is 1, so that y is equals to 1. So the conversion of 1 pi by 2 to Cartesian form is xy equals to 0 and 1. Right? Likewise, we can take one more example with some different values. Say we have r equals to minus 4 and theta equals to minus pi by 4. So let us try to justify the relation. X is equals to r cos theta, y is equals to r sine theta. Again put up the values which we are given, minus pi by 4 and y is equals to minus 4 sine of minus pi by 4. As according to the result that cosine is an even function, so cos minus pi by 4 will be considered as plus cos pi by 4, and as the sine is an odd function, that minus sign will be taken outside, so that this becomes 4 sine pi by 4. So your answers will be minus 4 into 1 upon root 2, that is x, and y will be 4 into 1 upon root 2. So your answer will be nothing but minus 2 root 2 and plus 2 root 2. So in that way, these polar coordinates are converted to Cartesian form. As in the same way as we are converting the polar coordinates or Cartesian coordinates into Cartesian or polar form, we can also convert the polar equations and Cartesian equations into the various forms. For that, we'll take some examples again. Suppose we have to convert one Cartesian equation like x square minus y square is equals to a square. So to do this, we'll use again the same relationship. Let us take x is equals to r cos theta, y is equals to r sin theta, and we'll put up the same values in the given equation. We'll be having r square cos square theta minus r square sin square theta is equals to a square. So definitely this r square be taken as common value. We'll have cos square theta minus sin square theta is equals to a square, so that r square, and again the trigonometry identity that cos square theta minus sin square theta will be taken as cos 2 theta, that is equals to a square. This equation which is obtained in the box is our required equation. So for the sake of the simplicity, we will take one more example for the same type. Say this time you have the equation x cube equals to y square into 2ax minus, the equation is x cube y square 2a minus x, and now this is supposed to be converted in terms of polar form. So again we'll consider x is equals to r cos theta, so this value will become r cube cos cube theta, y square will become r square sin square theta, and the answer in the bracket will become 2a minus r cos theta. So by some basic simplification, we'll be having r cos cube theta sin square theta into 2a minus r cos theta. So further simplification will give you r cos cube theta is equals to 2a sin square theta minus r sin square theta into cos theta. So this is how this Cartesian equation is converted into polar form. So in the same or the reverse manner, we can convert the polar coordinate like polar equations into the Cartesian form also. So for that, let us take one more example. Now we are considering one polar equation. Say r cos theta is equals to 2 sin square theta by 2. So again we will use the relationship x is equals to r cos theta, y is equals to r sin theta, but at that time we have to convert this equation in terms of proper trigonometric form using some basic identities. So left hand side there will be no change, and for right hand side we have a very basic identity, sin square theta by 2 becomes 1 minus cos theta with the reference of 2 sin square theta is equals to 1 minus cos 2 theta, but right now we have theta by 2. So now we can replace r cos theta as x upon r is equals to 2 1 minus x upon r. So r will be cancelled from the left hand side. X is equals to 2. You can take r as an LCM. So r will be multiplied with x, like rx is equals to 2 r minus, this is only 1 minus cos theta, not 2, that is r minus x. So you take this r at the other side, you got r into x minus 1 equals 2 minus x. Now in place of r we can put under root x square plus y square into x minus 1 equals to minus x, and for the simplicity we'll take the square both sides. We will get our required equation x square plus y square x minus 1 square is equals to x square. So in that way we can convert this Cartesian equation. Now one more example for the same type to make this idea much more clear about. We'll take one more example, that is r cos 3 theta plus sin 3 theta equals to 5k sin theta into cos theta. This entire equation is now to be converted in terms of Cartesian form. So at the left hand side we have two well-known terms, cos 3 theta and sin 3 theta, for which we have the formula like cos 3 theta is converted in terms of 4 cos cube theta minus 3 cos theta, and sin 3 theta will be converted as 3 sin theta minus 4 sin cube theta. So let us try to apply the same thing that I have told you. R into 4 cos cube theta minus 3 cos theta plus 3 sin theta minus 4 sin cube theta is equals to 5k sin theta into cos theta. So wherever you have cos theta you can replace it by x upon r, or wherever you have sin theta you can replace it by y upon r. So let us try to continue the things. 4 x cube upon r cube minus 3 x upon r plus 3 y upon r minus 4 y cube upon r cube. In the same way the procedure will be applied to right hand side also. 5k y upon r and cos theta is x upon r. So at the left hand side in the bracket you can take r cube as an LCM. So as a part of the work we got 4x cube minus 3xr plus 3yr minus 4y cube upon r cube equals to 5k xy upon r square. So in all, by the simplification we can cancel out the r values throughout, and now wherever you have r you can put up under root x square plus y square. So your answer will become 4x cube minus 3x. So r square will be converted in terms of x square plus y square plus 3y. R square again can be